Welcome. Thank you all for being here. It's been a long time no see. I guess there are some nervous speakers here today, me including. It's been a while, over a year, since I did a live talk. So I'll just try to imagine all of you like in Microsoft Teams or whatever you're using. It will be easier. So, my name is Mufrid Krilic. I work in a consultancy called Cowork. We provide, among other things, training and coaching, Tight Loose Tight, you might have heard of. Also, we are collaborating with nice people here at NDC, provide some workshops on some of the things I'm going to talk about, so please do check it out. Now, what's really interesting about Cowork is there is a book we've all read that kind of guides us through our struggles, our crossroads. And the book is Reinventing Organizations, written by Frederick Laloux. I recommend it because it will intrigue you in some way. It may change the way you look at organizations and the work itself. It certainly did it for me. It may provoke you, and there are some well-founded criticism on the book in the academic circles and in this community as well. However, it won't leave you, it will give you something. So please read it. It will be a topic of another talk, so I won't talk too much. But in this talk, I will go through some book recommendations. So all things left equal, you will leave with some books to read if you're interested. So the topic of my talk is aligning subdomains with bounded context and legacy code. So I feel compelled to explain what do I mean by subdomains and bounded contexts. Perhaps we all agree what do we mean by a legacy code. I'm not sure, do we? For me, a legacy means heritage, something valuable that we have inherited. And this talk is actually a homage to two of my former teams. We had some hardship, we endured some hardship together, we learned something together, and we had a lot of fun. So this talk is kind of a symbiosis of what we have learned and a story of our something we attempted and trying to share it with you. So this talk is for my former teammates. So this legacy code apart, what do we mean by bounded context and subdomains? Those terms kind of originated, or at least are mentioned fairly often in domain-driven design. So domain-driven design, you might run into it in this conference, and I'll try to cover some of the most important aspects, start with it. So I'll start fairly like bird view perspective, try to cover some background stuff, some theory, before we go into the more details. So the more we progress during the talk, the more detail we will get. So let's start with strategic domain-driven design. These are some things I'll talk about: core domain, problem, solution space, language, and what constitutes the pillars of domain-driven design. So, core domain. This is probably the most important question you can ask yourself, regardless of whether you're doing domain-driven design or not. What is your core domain in your business? What is the thing that sets you apart? What is the thing that gives you competitive advantage? It might not be an easy question to answer, especially if you've been in business for many years. Corporate environments in legacy, with the legacy systems, they do many things. What is their core thing? However, if you manage to answer that question, you will also see that there are other parts of the system that are not your core domain, still they need to be present to achieve your purpose. And so let's start. Example: if you're talking about passenger flight business, if I'm providing passenger flight travel, what's the core business for me? It could be ticket pricing algorithm, what sets me apart from my competitors. But of course, I need other things. I need passengers to check in on the flight. I need aircrafts. But maybe I buy the same aircrafts as my competitors. And so I would call the check-in system and aircraft inventory supporting subdomains, something that I need to integrate with. And there will also be some generic stuff, like website authentication. We need that. People expect to book things online. So what sets these things apart? Core domain is what you do yourself. Supporting subdomain is something you can outsource or customize in some way. Generic subdomain is something you can buy off the shelf. Having covered this, the conclusion is that not every part of the system will be well designed. You want to put your focus on a core domain. You want to have your best people there. You have your most training there. And you want to spend less time on other parts of the system. So defining this domain thing, subdomain term, leads us to problem space and solution space. It's in problem space that we find domains. And we try to discover those inherent subdomains. That is meaning that there are some inherent separations of concerns in the business itself. Trying to discover how the business and the domain works without the IT systems involved. That's the problem space. Solution space is that's your application, that's your IT system. So how do you structure your system? Could you use something of the learnings from the problem space, from the analysis you just did, to model your applications? That's where you create those bounded contexts. So now we are trying to align subdomains with bounded contexts. That's the kind of overarching topic here. At some point, even though the recommendation is to try to align those subdomains with bounded contexts, you will never get exact match. So do not strive for it either. Just try to learn from it. If you see there is a mismatch, just do not enforce it. Maybe you can model your application differently to get those two terms closer to each other. So what domain-driven design brings to the table is this notion of language. Could we use language to analyze the problem space, to analyze the subdomain? And all the language exists in a context. The natural language, you use English. You have Australian English, Canadian English, British English. They might have the words that spell the same, but they have different meaning because the language always exists in a context. The same goes for the business language. When you discover that the domain experts use the same term, but they mean different things, that is an indication of different contexts that you could take advantage of. Once you found those contexts where one term has a precise meaning, then you use that same language everywhere, in your code, in your conversation, in your documentation, within the context. And then we have those two pillars of domain-driven design, ubiquitous language or bounded context. Kind of difficult thing to pronounce, ubiquitous. But your bounded contexts are defined by linguistic boundaries. That's what domain-driven design suggests. Use your language to perform domain analysis, and then you can use that to model your application. And there we go for next book recommendation, of course. It's the book on domain-driven design. the Blue Book, as we call it. It was published 2004 and still very much relevant. So do consider it. Okay, so so we talked about subdomains and contexts and we're kind of assuming that there are some separations and some boundaries involved in whatever you do. So why are boundaries important? Well, you have to make sense of the problem space. It's easier to reason about your problem if you can reason about smaller parts at a time. We all want to align with the business, align the technological efforts with the business. So what do we mean by that? Well, if we do that, then we will reduce the translation efforts that developers don't use another language than the business experts. That is this ubiquitous language. This picture was not, it's not by chance, it's there. When complexity hits the fan, your common sense won't help you. But that's the topic of another talk. Okay, another thing about boundaries is this cognitive load, the notion of cognitive load. It's not only on individual level, how much do I need to understand, but how much my team needs to understand. Especially in legacy environments, how do we navigate and understand the legacy code? Can we reduce the area we are operating in? And I would claim that those boundaries exist everywhere, even in the legacy systems that have been developed over many years. There are some things that are not related to each other. Could we at least enhance it in some way? So this cognitive load for the team helps the team be more effective. Another book recommendation that really puts this cognitive load in the spotlight is team topologies. What they do, they convey importance of team cognitive load as a parameter when you're establishing your IT architecture. So your architecture could actually be derived from the cognitive load the teams currently have. So that's about why the boundaries are there. But where do we find them? Where are those boundaries? Well, some of those boundaries are observable or more easily observable than others. So go tactical boundaries. Think about network. Network could be a boundary. The party A communicates remotely with party B. They are separated by a network. Network constitutes a boundary. It's observable. Your deployment units could also form a boundary. Whatever you put inside a container, it's kind of thing that's cohesive. That's within the boundary. That's you can point at it. That's a boundary. Organizational boundaries are also easily observable. You have a team that does one thing, and there are other team in the room next door that does something else. So that there are boundaries between the teams and the departments within the organization. So those are easily observable boundaries. But what about those boundaries that are not so easily observable? And I'm going to spend some time on it now. It's I will start with a paper that was written in 1990s sometimes by Mufrid Krilic. And he called it 4+1 view model of software architecture. This is the original figure from the paper. And what Philippe tried to convey to us was, if you look at the system from different perspectives, you will have, it will look differently. And your architecture will look differently with respect to the perspective you're taking. And it turns out that if you're building a distributed system of a kind, this model will apply. So if we try to start with end user perspective, we will see the pieces of the system that fulfill some business role. They perform some tasks, some functional tasks that they do some of use to the business. This is the logical view of the system. What are the parts of the system that do something that provides value to the business? When we program, when we develop, we structure the source code in different ways. We create classes, or if you're object-oriented, or we create types and functions if you do functional programming. You put things together in modules or Visual Studio solutions, repositories. That's your source control structures. So then you relate your understanding of the logical view over to development view. You package those things in deployment units. That's where you get your process view. So either you are packaging things so they can constitute some processing on the operating system, or are you deploying containers in the cloud or your Azure functions? Those are the process deployment units in the process view. The physical view is then the infrastructure itself. Are you running on your on-prem server park, or are you running in the cloud? Now, of course, the DevOps philosophy has brought together all these roles. But they still exist, even they do not relate one-to-one to certain persons. But one team can have all these roles. So, as I mentioned, the observable boundaries we find in physical view, process view, and we find them also more easily in development view. We can point in the source code structures. But those boundaries that are not so easily observable exist in the logical view. And when we talk about boundaries, we need to talk about dependencies. More often than not, no parts of the system, regardless of how well they're isolated within a boundary, can operate on themselves. There is some dependency to other parts of the system. Something is going on between the different parts of the system. And dependencies in the logical view are the ones that are the most costly. We all want a loosely coupled system. Well, if we want a loosely coupled system, then we need to look at the dependencies in the logical view. Those are the reason for increased coupling. If you think about it, if you go back to your system and you ask yourself a question, how much data do I pass across those observable boundaries? That will give me an answer on the quality of the boundaries that we have. So the amount of data passed across the boundaries leads to increased coupling. You may, of course, desire more coupling in certain parts of the system, but be explicit about it. We talked about bounded contexts in domain-driven design. So if you've defined a bounded context explicitly, having more coupling within the context, that's perfectly fine. So what we're talking about is how much do the parts of the system know about each other. There will be a talk tomorrow by Trond Urteland called Good Fences Make Good Neighbors. He'll go more into that about this, so do check it out. And when we talk about distributed system, the cost of dependence in distributed system may go up. So when we have those logical dependencies, and if you distribute those logical dependencies across development view and the process view, then we pay the higher price. Think about it. If the things that we separate two things into source code repositories, but they are cohesive, they integrate with each other. We need to check both. Often, it's a pain. We feel that pain while we're developing. Or if you are introducing a remote call between the two things that are cohesive, that talk often to each other, we feel that pain. So the logical dependencies being distributed come with a cost. And that pertains to microservices. So the point of this model is when you're going microservices or you're going distribution, start with the logical dependencies, start with the logical view, start with domain analysis. So the measure of interrelationship in different parts of the system, that can lead to systems that are hard to maintain and hard to change. Okay. So let's start our story. This was kind of background stuff, theoretical background that I felt it was important to talk about. But let's start to make this a bit more concrete. It's a story about a team dealing with a legacy system. So a couple of years ago, we found ourselves in this position. This happens in the organization many times for whatever reason. People leave, new people come in, or people like to do other stuff, or there are some business reasons for restructuring everything. That happened to us, happened to me. So it was a group of people, actually not quite familiar with each other, but found themselves in position to, okay, you have to maintain this legacy system. It's been developed like more than 5 years back in time. How can you, what can you do? Okay, so let's start with what we learned from theory and do some domain analysis. So I'll show you a use case and to build ground for our attempts to do something more technically about the legacy system. So we were in the healthcare domain. This was our business, prescribing medications. That was our core thing, to enable physicians to prescribe medications. And we had to integrate with systems for delivery in pharmacies. And patient needs and safety was like really important here. We saw that. And so we tried to discuss with our business users. Can you walk us through some use cases? So I'll walk you through 2 use cases here. Now, in room 4, there was a talk by Henning Schwettner about carving microservices out of the monolith using domain storytelling. So I'll show some domain stories right now. So for those of you who've been in the room 4, so this could be familiar stuff. For others, I trust domain storytelling to be self-explanatory. So this is a use case. How do we prescribe medication straightforward? So we have a patient that has a consultation with the physician. And the physician, she decides to prescribe a medicament and looks whether or not the medicament is in a national database of approved medications. The medicament is there. Then we send the prescription. The physician, she sends prescription to pharmacy delivery system. Pharmacy delivery system notifies pharmacy about the prescription is ready, and the patient shows up and collects it. Really straightforward. So another use case is non-approved medications. So what I mean by this, in most countries, there is some board of national authorities that decide what medications can be prescribed by physicians. However, in some cases, due to national mismatch across the countries, physicians might decide to prescribe a non-approved medication. For instance, if research results from other countries indicate it could be beneficial for the patients. However, the physician must apply for approval. So let's walk through this. So patient, again, has consultation with physician. She could not find the medicine in the national database of approved medications. So she actually applies for approval to this national authority system. And let's say that they approve the application. However, this response to the application may arrive sometime later, perhaps days later. And then we repeat the story from as we left it in the last use case. Physician sends prescription to pharmacy delivery system. We send prescription back. We notify the pharmacy, and the patient can collect the system. So this was kind of a use case that this difference between those use cases intrigued us in the team. Are we on the verge of discovering a subdomain, something that is separate to the core process? So let's look at it. But before we go there, another book recommendation that is about domain storing itself, freshly published by Henning, who did a talk here today, and Stefan Hofer. So you will learn a lot not only about the method itself, but the modeling and the collaboration. Do check it out. Okay, so we are there, understanding the domain in our team, feeling more and more confident, and then we ask ourselves questions. Okay, can we find something from these two use cases that stand apart related to each other? Can we find those subdomains? As I started with, I believe that all systems, even those dreaded big ball of mud systems, whatever that means, there is some separations of concerns if you look closely. So could we find, this was not a big ball of mud, but anyway, it was difficult for us to comprehend the whole. So could we find something that we comprehend? And our target was, can we do something with it? Can we establish a bounded context? Can we do something regarding with this 4+1 model? Can we make a more observable boundary of the things that are separate, related to each other? So, what we did, we found out that, okay, there is this event, a non-approved medication prescribed, or something like that. And we called it pivotal event, or I believe this term comes from event storming, for those of you familiar with event storming. It kind of means that the most significant events in the domain are pivotal events. There are some heuristics to find those pivotal events. We believed at the time this was a pivotal event. Why? Because it kicks off a business sub-process of sending and approving an application. It's kind of a separate thing, or so we thought. Another thing was this time-related activity. The time is a funny thing. And in my experience, we model time we do not model time explicitly as we could in IT systems. So when we saw this time delay that a physician waits for approval of the application, meaning that she stops doing whatever she's doing and does something else, and when the approval arrives, then she proceeds with consultation or calls back patient, hey, we got our application. So those two things combined indicated that this could be on the track of a subdomain. So back to our domain story, we try to carve out this subdomain. This sending and receival application, is this a subdomain? It could be, looks here, and this time delay was kind of have a significance. So we could be onto something. Okay, good. And but we are dealing with legacy systems here, so we don't understand it completely. We understand it only partially. So let's go back to the code. Do we find any traces of bounded context? There was a team before us that developed the system. They did some decisions along the way. What are those decisions? Could we find traces of those decisions in the code? So are there any established boundaries in the development view that could indicate that there was some understanding aligned with what we seem to understand at that point? So we looked at those .NET projects, the namespaces, and there were some .NET projects actually separate to this course. With us, .NET projects that contain the code for application sending and receival. Wow, that was encouraging. And it was development view. Think all about this 4+1 model while we are talking. What about this logical view? And we did our homework, trying to do some analysis. Okay, go to the code. You see using statement. What can reveal dependencies? Using statements, .NET project reference, NuGet packages, remote calls, some events you receive from remote systems. We try to do that. This is rather time-consuming. It is essential because it really reveals how the system works. But it is time-consuming, so you have to take pros and cons here. How much time do you spend regarding the gains you get? Okay, so we are still felt optimistic. There are some traces of bounded concepts in the source code. Let's enhance it. So there we get to those bounded contexts, and then in domain-driven design vocabulary, we introduce something called context mapping. So our plan was this. Let's establish application-bounded context surrounded by some visible boundaries, and let it depend on prescription-bounded context, which was the core thing of our application. So we call this downstream, upstream modules. Why this analogy is a fine analogy. If you think of a river, whatever you do on the river upstream, it affects everything downstream. That's why we have application-bounded context downstream, depending on prescription, which is upstream. Those are terminology we use in DDD context mapping. And the relationship between two would be conformist, meaning that we will not spend any time customizing or translating the models. We will just refer to the code in prescription as it is. We want to establish this bounded context and then do those improvements later on. So that was our plan. Plans are a good thing. But it is legacy code we're talking about. This goes beyond saying. when you're working in legacy environments, you respect existing dependencies, relationships. So in my experience, you want to do explicit decision on the amount of work to break things up. So we are kind of trying to break things up a bit. Align with the business, still breaking things up. You want to keep business running while you make architectural improvements. So how do you do that? Okay, so decision time for our team. And this is what we decided. Let's do this. Let's establish observable boundary. That will be a Visual Studio solution. It will be observable in development view. I can point at it. This is it. We didn't want to change prescription bounded context. Just remain it as it is. That is the core thing. It just works as it is. We time boxed ourselves. And we said, okay, whatever happens after 1 week, we will summarize the lessons learned. So we are assuming here that this application context exists in some form in the logical view, hidden though it might be. And the dependencies are towards this prescription context. Those logical boundaries are there. That is our essential assumption. So, off we go. Step 1. Let's do this. Let's establish this solution. This is pretty straightforward thing. We just moved those .NET projects between solutions within the same repository. This kind of illustrates the value of 4+1 model. So we are establishing logical boundaries. We are establishing boundaries in the development view, but that doesn't mean that we have to deploy those things apart. We could still deploy them together. So when we talk about monoliths, I would recommend looking at 4+1 model. What kind of monolith are we talking about? Are we talking about monolith in process view, monolith in development view, or monolith in logical view? So you might have fairly well-designed modular system logically, which uses simple deployment strategy. This monolith thing can exist on different levels. But this was straightforward. We moved thing in a Git and used the Solution Explorer exclude include project. Worked well. Code did compile, unit tests was run. However, we did have those integration tests. So what I mean by those, you all seen this test pyramid. I'm sure of it many times. And for all those pyramids, the lowest level is always the same. It's always unit tests. What comes up, it's sometimes it's service, sometimes it's integration, sometimes it's contract tests. Many good names for this one, many terms. So I copied this one. We have integration end-to-end tests. So to me, those tests that's above the unit test level are some tests that span several units. They're connecting them. They're simulating runtime behavior. So we had some tests that simulated our runtime behavior. So what about those tests? So we found out that at unit tests, they rely on mocking, right? So they cannot warn us if there's some piece of code that expects to dynamically inject a dependency that has been moved somewhere else. We've just moved some code around. But those end-to-end tests could discover that. What should we do? Should we work on those tests, make them work, to get early feedback on runtime simulation? But we found out that it could take so much time that we actually delay the feedback we were after, we were looking for. So it could slow down the feedback loop. It was not an easy decision, but we decided just unit tests. Ignore those integration tests for now. It seemed like a good idea at the time. So, step 2. We move the code. So we go back to the this prescription context where we move the code from. Let's clean up those. It should be a lot of obsolete references there, right? That should be many using statements we just delete or .NET project references. And there were a lot of them, but some of them uncovered hidden dependencies. So it was a rather useful step. I'm not sure how conscious step it was, but it turned out to be an essential one. So what we discovered, there were some types defined in application-bounded context that were referenced from prescription-bounded context. So we got this dependency back. We didn't want this one. Can we do something about it? Okay, let's go back to what we learned so far in stable abstraction principle. Packages that are maximally stable should be maximally abstract. So it turned, it looked to us, seemed to be that those classes and interfaces that are defined in this application-bounded context did not contain any behavior. They were just abstractions. Okay, so can we extract those common type definitions to a separate model to using the stable abstraction principle? Create a module that is stable and abstract. So we did this. So in step 1, prescription-bounded context, referred application-bounded context using those application types. We moved those types to a separate model, and we moved the reference from prescription-bounded context. Now we had a common module that both contexts referred to. We didn't change anything in prescription-bounded context logically. We just moved the reference. So it was still complying to our notion of not changing anything in the core context itself. In the DDD context mapping, this is called shared kernel, where two contexts share a subset of the domain model. Actually, this shared kernel concept works very well if you're thinking about different teams. Now, this was only one team, but two modules. Nevertheless, shared kernel seemed to define this operation fairly well. So we established this, we felt good, we used stable abstraction principle. Are we ready to make those end-to-end tests run? And that's kind of there. Stopped. No, didn't work. So it turned out that some integration tests or end-to-end tests in prescription context required code from application context. Why? This was our assumption that it goes only one way, from application to prescription, those dependencies. Well, it turned out it was a valid business reason for this. And now the difference from at this stage from the past stage when we discovered those classes and interfaces that didn't have any behavior, that if we proceed with this attempt of ours, we would separate the two contexts, but the logical dependency would still exist, because now was the business reason for the circular dependency. We didn't want that. So this illustrates, hopefully, the point of cost in distributed system. When you separate the things that are cohesive, you pay the higher price. So we unlocked achievement, business requirement. We understood something. This is important. So as a physician, while we're prescribing this non-approved medicament, I want to see earlier applications for the same medicament. It could be that the patient has a lifelong prescriptions on the same medicament. I want to see if we have already sent an application. This required this dependency. It was a valid business reason. So this could as well been related to the shared kernel discovery we had in step 2. We didn't see it at the time. And it's also made us think about, okay, perhaps the model, the assumption about business understanding, those subdomains, were already done by the former team. They've been on this voyage already for us, and they had some decisions. Okay, these are cohesive things, not worth separating. But we it was kind of, okay, why didn't you ask somebody? Well, this was one of those unknowns. You know, you don't know about this until you're there. Now we knew. Okay, we learned something. On a side note, I tried to express this requirement in a conventional user story template. Perhaps you see a difference between using text as a communication medium versus the visual domain stories to formulate how the business works. I prefer visuals. I don't know about you. Okay, one last push. We are not done. We are stubborn gang. Can we avoid those circular dependencies? Can we move all those integration tests to a separate module and make that depend on everything else? It will work. All DLLs would be available. Yes. So deployment-wise, deployment view, that would be fine. However, this logical view, those circular dependency logical view would still exist. So we would just separate things that are cohesive. So that's the lesson from 4+1 model. You separate things that are logically separable. So, now what? As this lovely gang from Pixar movie Finding Nemo, we had a good plan. It worked almost. Well, I wrote a blog post about it, and I got a very interesting suggestion. Mauro Serviente read a blog post and suggested view model composition. And he asked, Mufrid, is it like that the physician needs only to see those prior applications? So the physician applies for non-approved medication and needs to see those earlier applications. Is it only decision time support data? There's no action, no behavior, you just want to see it. Okay? I believe so. Then you can do view model composition, which composes data from different bounded contexts on the front end. So what's kind of, I won't go into depth of all those micro front ends, thematics and everything, but the promise of microservices or the promise of modularity or whatnot, SOA, is that we have those services. And I believe we tend to think about them as a back-end thing. They exist on the back-end. What about front-end? So we have all those nicely decoupled services, and then just everything merges together on the front end. So that's where view model composition comes into play. Let's services that are defined their data ownership. Let services own the data also on the front end. So I won't get, I don't have time to, or I haven't prepared it at least, to go into depth of view model composition. There are some discussions of view model composition versus UI compositions. They are different things. Check Mauro's blog. He has tons of articles on it. And it's one of the really powerful techniques to achieve a loosely coupled system. So you can get your front end as modular as possible. Okay, so back to our team. And these are the things that made me really proud to be part of this team. So what we did in the aftermath of this one, when we those 1 week has passed and business comes back, okay, what now? Do we have a more modular system? We have learned something. But what we started it is we start with regular architectural reviews. Once a week, we would talk about things we didn't understand. Just a bunch of guys, and maybe we could get somebody else in the room to help us, but let's be stubborn about it. Let's be stubborn about learning. Let's learn more. This didn't work quite out, but let's do it now. Next time we try, we will have better equipment to do what we want to do. And they still do this. I've left the team, but they still do this. Great gang. I'm really proud of it. This was a great thing. So stable abstraction principle. That's an interesting one. Could we define, when we have different, we have some source code structure of a sort, some modules in our repositories, can we define how do we want the relationship to be between those modules? What should be more stable, more abstract? What shouldn't be? And then try to enforce it. So try to draw an ideal as-is picture of your source code relationships, dependencies. And then can we use, okay, so next time we introduce dependencies or abstractions or dependencies or boundaries, let's try to enforce the stable abstraction principles. The next point was a really a quick win, and I wholeheartedly recommend it. So those logical dependencies, as I try to claim here, they are not so easily observable. You have to dig to find it. But when you do it continuously, as you code, as you develop your system, you may find it. Code review is a great place to do that. So next time you do code review, okay, new using statement introduced, new .NET project reference introduced, new NuGet package, you stop and ask yourself why, or your comrade, why did we do this? So this is the way of discovering logical dependencies, those small hidden things that, and of course your IntelliSense tool of your choice might not be your best friend. Sometimes you do those shortcuts and they just pull the reference in without you making any explicit claim about it. So, so that's why code review is a good place to do this. And that way, you actually you have a concrete action step to employ 4+1 model in your daily work. And you can always make things more cohesive. Kent Beck said that in a wonderful talk in Domain-Driven Design Conference last year. That's the link. Check it out, please. So as code review goes about the code that has been written, when you start on a new something new, you add some new piece of functionality. So you can buy yourself some time to try to hold things separate to begin with, not to make them cohesive. It's because it's always easier to make things more cohesive. What is difficult, as this story showed, is to split things apart. So loosely coupled is difficult. Cohesive is easy. So you start by holding things separate. You give yourself time and you learn, okay, these are separate things, I keep them separate. Oh, these are the same thing. Okay, I'll just make them more cohesive. It's easy. It doesn't take a lot of time. So, the last book recommendation of today, if you're working legacy code, read this. Oi, for a fabulous book. You don't have, it is like 400 pages or something, but you don't have to read it page to page. Just open table of contents, and I guarantee you will find something there that is important for you today in your legacy environment. It's incredible. Whenever I open the book, I found something that I worked on today. Okay. So we are approaching the end, and one last minute for the most important thing. I use every opportunity to talk about this. This was all fine and good, but now comes the most important thing. First Lego League. That is the technology science competition, the worldwide competition for children and youth aged 6 to 16. I believe it's our responsibility to devote some of our time to help children develop their programming skills, technology interests, be more curious. So we want to inspire next generation to consider their career path in our profession. And we have to start when they're young. I devote a lot of my time and encourage you to do the same. First Lego League is everywhere in the world. Wherever you come from, you will find a First Lego League team. So please consider it. Thank you.